Welcome to Year 1 Mechanics, Chapter 9.3, where we start looking at Suvat, also known as kinematics. The Suvat formulae will be broken into two lessons, two parts. This is the first part. In total, you'll be learning five formulae, and you'll be learning, two of them in this video. So before we start, we have to learn about terminologies and units and variables. So you can make a little table to show you, okay, what are the five variables we are looking at in Suvat. Actually, Suvat, it tells you, it gives it out, the Suvat, S-U-V-A-T, they are the letters. So we can, essentially, we can write them out, as in the letters going to be S-U-V-A-T, right? So S, I think I did mention last lesson or last video, S stands for displacement. So displacement, you can think of similar to distance, where I mentioned about the example about McDonald's, going from home to McDonald's is positive displacement, but coming back will be negative displacement. So altogether, if I go from home to McDonald's and come back home, I would have zero displacement. Technically, I've not moved apart from my stomach. So positive. So when is it positive? When a particle, when it's moving, okay, when it's moving up or right. We tend to use up or right as a positive displacement. And when it's negative, when you're moving, okay, left or down, or left. Okay, so we tend to use a negative displacement for that. So unit is we use meters. Okay, it's standardized as meters. U is known as initial initial not display, velocity. So what is velocity again? Velocity is similar to speed. The velocity time graph, speed time graph, they're sort of similar thing, but velocity is a vector. It has direction, whereas speed has no direction. It only has magnitude. It's known as a scalar. So velocity is a vector. So positive again is moving up or right. Then it's positive velocity. Negative means we're moving left or down. Okay, unit is called meter per second. V is called final velocity. So the speed of the particle when it reaches its destination. Destination does not mean the final destination. It depends how we define a journey, right? So let's say a journey from home to McDonald's. The final velocity might not necessarily be the speed at McDonald's. If I want to measure, the speed from home to, let's say, 10 seconds after I left home, then I could do the final velocity at the time equals 10. So the final velocity or initial velocity depends on where you start measuring your journey. Okay, but we'll talk about that more later in examples. So when is the final velocity positive? Or same thing if it's up or right. Okay, and same thing here, left or down. Unit will be same as initial velocity, meter per second. Again, they are speed. All right. Now, acceleration A. Acceleration. Now, acceleration, even though it's a vector, the sign, whether it's positive, okay, so when is it positive or negative, okay, does not depend on the direction. Okay, so these three depends on the direction. All right, it's all about the direction. But acceleration depends on whether it's actually, it sounds stupid, but it's actually whether we're accelerating or not. Okay, so it doesn't matter which direction we're accelerating. Okay, as long as we are accelerating, then A will be positive. If we're decelerating, then it will be negative. Pardon my writing. Let me write it better. Decelerating. Okay, so the unit will be meter per second squared. Now I want to put a note in here, okay, in here. So the sign, or not, the sign of acceleration doesn't depend on the direction particle is moving. Okay, so it does not. So on the contrary to the S, U, and V, it does not depend on which way we're moving. Okay, as long as we are accelerating, either backwards or forward or upwards or downwards, we are having a positive acceleration. Okay, positive value of A. So mind that. All right. In here we might want to put a notes in here. So let's say walking right. So for displacement will be positive 10, run out of space, positive 10 meters. Okay, walking left will be negative 10 meters. So net will be 0 meter. Okay, so that's the displacement. All right, let me write it in meter. So that's the positive 10 meter. Walking left will be negative 10 meters, so net will be 0 meter. Just to explain about displacement. And T, we know what T stands for. Okay, T obviously stands for time. Positive, always. T is always positive. Time is always ticking, so is our lives. Negative, never. All right, T is never, time is never negative. Okay, unit, seconds. Right, simple. Right. So next, Suvat formulae. You're going to learn 5 formulae. Okay, so we're going to write number 1. Okay, they're not in any particular order, but it's just taught in this order, so as the textbook does. So the first one is V equals U plus AT. Now these formulae are given in the formula booklet. Now, even though it's given in formula booklet, okay, I think it's never a bad thing to remember them off by heart, because when you need to use it and you check a formula booklet, you're wasting quite a bit of time in exam. So the best thing is obviously remember them off by heart. And as you do a lot of practices, a lot of questions, so hopefully you will be able to remember them, off your mind anyway. So V equals U plus AT. The second one is S equals U plus V times T over 2. This is actually a trapezium, area of trapezium, the formula. Okay, is that a coincidence? Actually, it's not, because this actually derived from the ST graph. Yeah, I'm not going to go for it now. Anyway, so yeah, so remember these 2 formulae. Okay, right, example. A particle Q is moving from point A to point B. So particle moving from point A to point B. All right, so that's a particle from point A to point B. With constant acceleration of 3 meters per second squared, its speed at A is 2 meters per second. So that's speed in here, 2 meters per second. And it takes 8 seconds to move from A to B. Find the speed of the particle at B. So what we do is we use Suvat. So we're going to set up a little table. Okay, Suvat. Okay, some people like to set it sideways, as in next to each other, but I like to set it downwards, just a habit. So S. So do we know what displacement? S is distance or displacement. Now the best thing to do is you can refer back to this table. Okay, look at the unit. You look at any numbers with the unit meters. There's none of them, so we don't have S. Initial velocity. Okay, U. Initial velocity is 2. We start from 2 and we ended with, we don't know. So that's what we want to find out, the speed at B. So that's the final velocity. All right, so this is the initial. Okay, so this is the initial. This is the final. Okay, so that's U and that's V, just to make you aware, because our journey is from A to B. So initial velocity is here, final velocity is there. Right, A acceleration. Yes, we do know acceleration is 3. We're accelerating. And time, it takes us 8 seconds. So the formula I want to use is the one without S, because we don't know S. Okay, we don't care about S for now. So we want to use V equals U plus AT. So V equals U plus AT. V equals 2 plus 3 times 8. So V equals 24 plus 2, 26 meter per second. Right? Easy peasy. Next one, part B. Find the distance from A to B. You can imagine find the distance means to find the displacement in this case. So we want to find S. To find S, we can use S equals U plus V times T over 2. S equals to U, 2 plus 26. Now, because we know V times T times 8 divided by 2, which is, put in the calculator, 102 meters. Okay, next. Right. Next example. A particle moves in a straight line from A to B. So let's try draw a diagram. Okay. So A, it's always a good thing to draw a little diagram just to illustrate it. Okay, A to B. With constant deceleration. Deceleration means negative. Minus V means a short form for negative. Again, I like to use short form, so negative. Okay, so that means it's negative 1.5 meter per second squared. Its speed at A is 8 meters per second, and B is 2 meters per second. All right, fair enough. You can see the speed actually goes from 8 to 2. Makes sense because we're decelerating. All right. Part A, find the time taken from point A to point B. So point A to point B, let's have a Suvat table. So what we know is U is 8, V is 2. A is negative 1.5. To find the time, okay, we can use the formula V equals U plus AT. So V is 2, U is 8, A is negative 1.5 times T. So you should solve it. Minus 6 equals minus 1.5 T. T equals to 4 seconds. Right? So it takes us 4 seconds. So I'm going to edit on there. I'm going to just a different color to show you this is information that we've got after the calculation. Okay. Part B, to find the distance. Well, to find the distance, we can use same Suvat because we'll find S. So S equals U plus V times T over 2. So S equals to 8 plus 2 times T, which is now we know is 4, divided by 2. So 8 plus 2 is 10. 10 times 4 is 40, divided by 2 is 20 meters. All right, so we now know this is 20 meters. Right, next part of the question. After reaching B, the particle keeps moving to reach point C. All right, so keep moving to point C. It takes 6 seconds to move from A to C. Takes 6 seconds. So from A to C takes 6 seconds, but A to B takes 4 seconds. So what we know is B to C takes 2 seconds. Okay. Find the velocity of the particle at C. Okay. So find the particle at C. Now, here's a question for you. Okay. We'll set a Suvat formula, a Suvat table in here, SUVAT. Could you guess if we could use the same table, or do we have to set a new one? Why or why not? We should set a new Suvat table because this Suvat is from point A to point B. Now, I'll suggest you to do this, okay? If your question involves more than 2 points, then get a habit of writing the journey which part of this Suvat table belongs to. This Suvat table helps you work out anything from A to B. Anything that's outside of A to B, you have to set a new Suvat table. So just to clarify, okay, I put an A to B in here because this table belongs to A to B. When we work out something with C, that means we need a new Suvat table. I guess the thing we could do in here is we can set up a Suvat table from A to C. Okay, from A to C. Now, could you set up a Suvat table from B to C? That's perfectly fine. That's perfectly fine. So I'll use A to C in here just because they give us 6 seconds from A to C. So anyway, A to C. Okay. I'll also show you how to set up a Suvat table from B to C if you're interested. So S. Well, we don't know the displacement from A to C. Now we don't know. Okay, this displacement is from A to C, between A to C. We only know A to B is 20, so A to C is unknown. Initial velocity. The initial velocity at 8, which is at A, which is 8. Final velocity at C, so final. Oops. So V means the final velocity. So these two letters have a good thing of telling you, okay, that's U and V. That's U and V. Okay, so we want to find the final velocity at C. Well, we don't know what it is because that's what we want to find. A. We know A is minus 1.5 because it has been consistent, and T would take 6 seconds, right? So you can want to work out V in here. So V equals U plus AT. So V equals to 8 plus minus 1.5 times 6. Put that in a calculator, you should get -1. Now let me ask you a question. Can velocity be negative? Yes, velocity can be negative. Why isn't so in here? Okay. Why negative? It means particle is moving backwards direction. So why is my writing so bad? Moving. Okay. So what happened in here? Why is the particle moving backward direction? Because A is decelerating. Remember, our speed is actually decreasing from A to 2. So what happened in here? Well, you can imagine that's A, right? And then we'll reach B, and then we're slowing down so much that we start to go backwards, and that's point C. And that's what happened because we're slowing down so much that the speed becomes zero. Once the speed becomes zero, we start to go negative. That means we are sort of reversing. If you think of a car, yes, think of it like a really weird car, new technology. When you're braking, all right. So when you reach a traffic light, okay, as soon as you hit the brake, obviously your speed goes down. Normal car goes to zero, but once you press the brake so hard, once you reach zero speed, it actually goes negative. Negative means start reversing. Okay, so I know it's a bit, so it's not what you see in real life, but that's what mechanics, that's what negative is for. Okay, because we're decreasing the speed so much, it becomes zero. Zero, keep decreasing the speed, becomes negative. Negative means move backwards. All right, part D. Part D, displacement from A to C. So we can use the same Suvat table. The reason being is we have this Suvat table is from A to C, so we can use the same one. So S equals U plus V times T over 2. We know U is 8. V is now minus 1. I'll put a minus 1 in there. So 8 plus minus 1 times 6 over 2. So S equals 7 times 6, 42, 21 meters. Displacement from A to C. Okay. Now, if you're interested in setting up a table from B to C, that's perfectly fine. So I'll show you. Okay. So part C, ought. Okay. Method for part C. So from B to C, Suvat. Displacement from B to C, we don't know. Okay. But we know U. Initial velocity. Now, initial velocity measures B. So that's 2. Final velocity at C, we don't know. But we know A is still minus 1.5 because the deceleration is consistent throughout the whole journey. Time, we know from B to C is 2 seconds. So V equals U plus AT. V equals 2 plus minus 1.5 times 2. So V equals to minus 1 meter per second. You see, get the same answer as long as you fill in the numbers correctly. Okay. And yeah. Okay. So, right, let's move on. Practice question 1. Okay, have a go these 2 practice questions. Okay, when you're ready for the answer, you can press play. Right, here are the answers. Okay, practice question 1 is V equals 20, 2, A is 0.625. It must be positive. Now, if your answer is negative, you must still write A equals positive at 0.625. The reason being is they're asking for deceleration. So if your answer is negative, yes, it represents deceleration. However, if you answer the question, it will become the deceleration of the car is negative 0.65. It means a double negative, if that makes sense. So therefore, the deceleration is 0.65. All right. Or you can say the acceleration, or you can rewrite a sentence saying the acceleration is negative 0.65. That way. Okay. So if you got it right, both of them right, that's it. End of lesson for you. Well done. But if you don't, let's go through why. So first of all, set a Suvat in here. Okay. So particle is moving at constant acceleration 3 at time t equals 0. That means initially. All right. That means initially. If you don't know, t0 means initially. Learn this. We've learned this actually in exponential modeling. When t equals 0, that's a very common trick of saying initially in modeling question. The velocity of the particle is 2 meters per second. Find the velocity when at time equals 6. So we want to work out v. So v equals u plus at. V equals to 2 plus 3 times 6. So V equals to 20 meter per second. All right. Question 2. A car is approaching traffic lights. The car is traveling with velocity 10 meter per second. 10 meter per second. So again, let's have a Suvat. Initial velocity is 10. The driver applies the brakes to the car. The car comes to rest. Comes to rest means final velocity is 0. So do you want to make you aware of that? Comes to rest means final velocity is 0. With constant deceleration in 16 seconds. Modeling particle, a car is a particle, find deceleration of the car. So want to work out A. So V equals U plus AT. V is 0, U is 10, A is unknown, T is 16. So if you bring the 10 over, it becomes minus 10 equals 16A. 10 divided by 16, put in the calculator, is negative 0.65. Therefore, okay, so deceleration is 0.625 meter per second squared. Now, if you leave your answers A equals negative 0.65, you actually lose the final mark. I'm not kidding. All right, so and we'll end the video here.